HD 189733b. This is a gas giant located about 64 light years from Earth, and its atmosphere gives it a deep blue color when viewed from space. That color doesn't come from water or oxygen, though. It comes from silicate particles, essentially fragments of glass suspended high in the planet's clouds. Winds on this world can reach speeds of several thousand kilometers per hour, strong enough to blow that glass sideways in what would effectively be horizontal glass rain. WASP 12b. This planet orbits so close to its star that it completes a full year in about one Earth day. The intense heat has puffed the planet up into an egg-like shape, distorted by the gravitational pull of its host star. Slowly but steadily, the star is stripping away the planet's atmosphere, pulling gas off its surface and feeding it into a disk of material that surrounds them both. Astronomers expect this planet to eventually be consumed entirely. 55 Cancri e, nicknamed the Diamond Planet by some researchers, this world orbits its star so closely that a year there lasts only about 18 hours. Early studies suggested its interior could be rich in carbon, compressed under extreme pressure into crystalline form. Its surface, meanwhile, is thought to be covered in molten lava, with temperatures high enough to melt metal. Whether or not the diamond theory holds up perfectly, the mix of extreme heat and unusual composition makes this one of the more debated planets in modern astronomy. Kepler, 16. Unlike most planets, this one doesn't orbit a single star. It circles two stars locked in a binary system, meaning that from its surface, an observer would see two sunsets and two sunrises. This kind of arrangement was once considered pure science fiction, something closer to a movie backdrop than a real astronomical possibility. Its discovery confirmed that circumbinary planets, worlds orbiting two suns, aren't just fictional, but genuinely exist out in the galaxy. TRES 2b, often described as the darkest known planet, this gas giant reflects less than 1% of the light that hits it, making it darker than coal or fresh asphalt. Instead of clouds made of reflective compounds, its atmosphere seems to absorb almost every photon that reaches it. Part of the reason lies in the extreme heat, since the planet orbits so close to its star that its upper atmosphere may contain light-absorbing chemicals like vaporized sodium and potassium. Rather than shining faintly like most gas giants do, it sits in near total darkness, visible mainly through the small dip it causes in its star's brightness as it passes in front. Gliese 436b. This world is sometimes called the planet of burning ice, a name that sounds contradictory until you understand the physics behind it. Surface temperatures reach several hundred degrees Celsius, hot enough to vaporize water instantly under normal conditions, yet the planet's gravity is so strong that it compresses the water vapor back into a solid state, forming a form of ice that remains stable even at extreme heat. The result is a planet where water exists as ice while still being hot enough to burn skin on contact, a combination that doesn't occur naturally anywhere on Earth. PSR B1620-26b. Nicknamed Methuselah for its extraordinary age, this planet is estimated to be around 13 billion years old, nearly as old as the universe itself. It orbits two collapsed stars, a pulsar and a white dwarf in a cluster of stars far denser than our own solar neighborhood. Its discovery challenged assumptions about how early in cosmic history planets could form, since it existed when the universe contained far fewer of the heavier elements needed to build rocky worlds. Surviving through billions of years of stellar evolution, including its star's transformation into a dead, spinning remnant, this planet stands as one of the oldest known objects of its kind. J1407b. This planet, if it can be called that, is surrounded by a ring system so immense that it dwarfs Saturn's by comparison, stretching roughly 200 times wider. If it replaced Saturn in our own solar system, the rings would be easily visible from Earth, spanning a portion of the night sky larger than the full moon. The system contains dozens of individual rings, and gaps within them hint at unseen moons carving paths through this material, similar to how Saturn's moons shape its own rings. Because of its scale, some researchers have nicknamed it Super Saturn, though its exact nature, whether a planet or a small brown dwarf, is still debated. Kepler 70b, sometimes called a Chthonian planet, this world appears to be the stripped-down core of a gas giant that once had a thick atmosphere. Orbiting extremely close to a hot subdwarf star, a stellar remnant left behind after a star sheds its outer layers. The planet likely had its original gaseous envelope burned away entirely. What remains is a dense rocky husk exposed to blistering radiation, orbiting so near its star that a full year lasts only a matter of hours. Its existence suggests that some planets we detect today may not have started out as small, solid worlds, but were instead reduced to their current state through sheer stellar violence. Coro 7b. On this planet, temperatures on the sunlit side climb high enough to melt rock, creating oceans of molten lava across parts of its surface, because the planet is tidally locked with one side permanently facing its star. That same side bakes under constant heat while the opposite side remains locked in freezing darkness. Scientists have proposed that its atmosphere may be made partly of vaporized rock, meaning clouds there could be composed of minerals that would rain back down as pebbles once they cooled. This bizarre form of rocky rainfall makes it one of the more extreme examples of weather found anywhere beyond our solar system. HD 106906b. This planet orbits its star at a distance so vast that it takes over 1,000 years to complete a single orbit, far beyond the reach of any planet in our own solar system. Its position is so unusual that scientists still debate how it could have formed in the first place, since planets aren't expected to develop naturally at such extreme distances from their star. One leading idea suggests it may have formed closer in before being flung outward by gravitational interactions with other planets, or forming more like a binary star companion than a typical planet. Either way, its immense, lonely orbit places it in a category of its own among discovered worlds. Kepler 22b. Located within its star's habitable zone, this planet sits at a distance where temperatures could theoretically allow liquid water to exist on its surface. Its exact composition remains uncertain, with scientists debating whether it is a rocky world, an ocean planet completely covered in water, or something closer to a small gas giant. If it does turn out to be an ocean world, models suggest it could be covered by a global sea many kilometers deep without any exposed land at all. That uncertainty, paired with its placement in a life-friendly zone, has made it one of the most closely studied exoplanets since its discovery. WASP 17b. This is one of the largest planets ever discovered relative to its mass, puffed up to nearly double the size of Jupiter despite weighing far less. It's also notable for orbiting its star backward, moving in the opposite direction to the star's own rotation, a trait shared by very few known planets. This retrograde motion suggests a violent past, possibly involving a close gravitational encounter with another planet that flipped its orbit entirely. Its low density and unusual orbital direction together make it one of the more structurally unusual gas giants known to astronomers. PSR B1257 plus 1, 2, B, C, and D. These worlds orbit a pulsar, the crushed, rapidly spinning remains of a star that exploded in a supernova. They were the first exoplanets ever confirmed, discovered years before any planet was found around a normal, living star. Life, as we know it, couldn't survive here, since pulsars bathe their surroundings in intense radiation and charged particles instead of gentle starlight. Their existence proved that planets can form even in the aftermath of stellar destruction, orbiting a corpse of a star rather than a star still burning fuel. Kepler 1520b. This planet is disintegrating in real time, shedding material into space as it orbits its star. Streams of rock and dust trail behind it, forming a comet-like tail made not of ice but of vaporized stone. Every time it completes an orbit, it loses a little more of itself, and researchers estimate it may not survive more than a few tens of millions of years. Watching it is close to watching a planet die in slow motion, one of the only known worlds actively falling apart in front of astronomers. HATP7b. High in this planet's atmosphere, clouds are thought to be made of corundum, the mineral that forms rubies and sapphires. Winds move fast enough to push these cloud formations from the day side to the night side of the planet, meaning the location and appearance of these gem-like clouds shift constantly. Temperatures swing dramatically between the permanently sunlit side and the darker side, driving some of the fastest atmospheric winds recorded on any known exoplanet. The result is a planet where the sky itself is built from the same crystals used in fine jewelry. Kepler 419b. This planet follows one of the most elongated orbits ever recorded, swinging from very close to its star out to a distance more than 8 times farther, all within a single year. That extreme path likely comes from gravitational tugging by a second, more distant planet in the same system. Rather than a smooth, circular path like most planets in our solar system follow, this world experiences dramatic swings in temperature and starlight exposure throughout its orbit. Its trajectory looks less like a typical planetary orbit and more like the path of a comet, TRES 4b. With a density lower than Cork, this planet is one of the puffiest ever found, so light for its size that it would float if placed in a large enough body of water. Intense heat from its star has caused its atmosphere to expand dramatically, inflating the planet's outer layers without adding much actual mass. It orbits so close to its star that its surface temperature exceeds 1,000 degrees Celsius, contributing directly to that extreme puffiness. Few other planets combine such enormous size with such little substance in quite the same way. Kepler 1625b. This planet appears to have a companion of its own, a moon roughly the size of Neptune orbiting around it, which would make it the largest exomoon candidate ever proposed. If confirmed, it would upend previous assumptions about how large a moon can be relative to its parent planet. The signal suggesting the moon's presence has been difficult to fully verify, leading to an ongoing debate among astronomers about whether it's real or a data artifact. Either way, the possibility alone has pushed researchers to reconsider how varied moon systems around distant planets might be.